Okay, so where should we probably start?
Q is the midpoint of line PR.
Yeah, we always start with the given, right? So the first step is always going to be given. So we know, whoops, we know Q is the midpoint of PR, segment PR, right? Okay, so now what? What do you think? What's our reason is given? Sorry, we know that, don't we? Okay, now we got to move down to the next line. I'll just change color so we can see when one line goes to the next. What do you think? So Q is the midpoint of PR. We're trying to show that this distance is equal to, is half of the whole thing, and so is this distance.
P plus Q equals PQ plus RQR. RQ equals.
So say it again.
PR. PQ plus QR equals PR. And that'd be the segment addition postulate.
Okay, we do know that. We do know that. There's one other thing.
Already did it out on the paper.
Okay, we'll do it. That's fine. We'll do it in that order. That's fine. So number 2, everybody agree? We know that if Q,
I don't know what
he said that the length of segment PQ plus the length of segment QR equals the length of segment PR, right? And that's just the segment addition postulate, right? So PQ, that's how we write it, right? Length of segment PQ plus QR equals PR, and our reason is segment addition postulate, right? Okay? Now what? Something that's always kind of good to look for, if they tell us like Q is a midpoint. Well, a midpoint is something special, right?
Yeah.
So do we know anything about a midpoint? What is, I hope this is on here. There might be some things that have been forgotten. We have a definition of,
Definition of a midpoint.
yeah, that should be on here, is it? Should be. Oh, there it is. Okay, midpoint formula. I guess I need definition of midpoint. I'm going to make a note. I'll have to add that.
Did we do something with the symmetric property of congruence?
We probably can. We'll probably get to a point where we can, yeah. So I need to add definition of midpoint. Okay, what is the definition of a midpoint?
A point that bisects a line.
Okay, so we know that if Q is the midpoint, then we know that it bisects the line, and so don't we know that that distance must equal that distance?
Yeah.
Right? Okay, so we could say then, and that'll be on there, we could say eventually, so we could say that PQ equals QR by definition of midpoint. Okay, so that gives us quite a bit of stuff, doesn't it? So if I know that PQ equals QR, what do you think? Remember, I'm trying to show, for example, that PQ equals 1/2 of PR. What do you think, Kurt?
Like on number 2, they're added together.
Ah, okay. So what are you suggesting that number line 4 should be then? You're onto something.
Oh, PR minus QR.
PR minus QR. Okay, true. And you maybe could go that way, but we don't need to necessarily. You were onto something real good there. What do you think?
You could change it to PQ plus PQ equals
sure.
QR.
Okay, good, because I know that PQ equals QR, right? That's where I thought you were going with that. So we could say PQ plus PQ equals PR, right? Now, what's my justification for that? I give you a hint, it's going to be under the general.
The symmetric.
I hope it's on there. Did I forget that one too?
Is it the symmetric? A equals B, then.
Oh, no, I think I forgot that one too. But we did it yesterday. I'll add this one too. This is going to happen for a couple days.
Is it the substitution?
Yep, it is, substitution.
The
Substitution, property of equality.
No, it's on the bottom.
Oh, it is?
Well, actually, no, it's.
Oh, it is. No, it is. There it is. Substitution, property of equality.
I don't see it.
It's about a third of the way down the front page, fourth of the way
It's
down the
only
front page.
one on the general that has the,
Two
two
lines.
lines.
Now, you'll kind of get the hang of this, but you don't always have to necessarily write property of equality. I mean, really, you could just, once you get going, like in a college class, you wouldn't say substitution, property of equality. You probably would just write substitution. But let's do it right. Substitution, property of equality. Okay, now what? We kind of talked about this a little bit yesterday. I'm gonna make this one red. Make it stick out. What do you think?
2 PQ equals P1.
Yeah, isn't PQ plus PQ just the same thing as 2PQ,
Mhm.
right? Okay, so step 5, 2PQ equals PR. Now, what's our rationale for that? Just simplify. That's all we're doing, right? We didn't change anything. We just made it look prettier, right? And then, last step, almost, I guess, kind of the last step.
1/2 of PR.
Divide by 2, sure, divide both sides by 2, and we get PQ equals 1/2 PR. Now, what's our justification for that? Yeah, division, property of equality, right? I can divide both sides by the same thing. Okay, so there's one of the two things I needed to show. That's proven. How would I do the other one?
You substitute,
You just-
it's substitute because, PQ and QR.
Okay, so PQ equals QR and PQ equals that, right? So then, now be careful with the reason for this. So therefore, we also know that QR equals 1/2 PR. How come? No, not really substitution. I mean, I guess you could. You could call it substitution, because you're just saying, that's fine. So substitution would work.
Symmetric property.
Or we could use also the transitive property, right? Does that make sense? Because we could say, 1/2 PR equals PQ, and PQ equals QR, so therefore 1/2 PR, you see what I'm saying? Either one would be fine.
On the transitive, shouldn't it be A equals B and B equals C, then A equals B?
Right, so QR equals
There you
PQ,
go.
and PQ equals 1/2 PR, so QR equals 1/2 PR, right? Either way, we call it either one. We'll just call it substitution. Either one would work though.
For transit property, it says
Oh.
if A equals B, then B equals C, then B equals C.
Uh-oh, which one, transitive property?
Yeah.
It doesn't say that
It says,
on mine.
Oh, what's,
Yeah, it says an A equals C on mine.
transitive property.
Mine says A equals C.
Same here.
Mine says B.
Oh,
Oh, wait.
You're looking at the property.
oh, you're looking at congruence. Yeah, the one for equality is messed up. I'll fix it. You'll find, let me know when you find them. Does that make sense?
No, it's. Where is it?
Okay. So what did we do? That's kind of cool. We went from just that little bit of information, we proved, because each step was justified, we proved beyond a shadow of a doubt that those two statements are true, right? Okay, how about,
Can you ever like measure,
what's that?
can you ever
Hang on.
could you ever like measure half on ruler and you just say?
Not really, not mathematically. That wouldn't be, mathematically, we wanna show it using steps that are, yeah, mathematical, that don't involve measurement, right? That are gonna be based on just, and really, they just boil down to theorems. You're gonna see lots of things in the book. You see lots of these reasons that we give are theorems. We have postulates and theorems and definitions and things like that. Well, theorems have all been proven. Theorems have to be proved before you can use them. So a long time ago, the geometrists, and that's what they were called, these people that started doing geometry, they just started proving stuff, and as they proved it, they just accumulated this list of theorems that they could then draw on for other proofs, right? The ones that we list on that are listed on that sheet are just the ones that are so common that we just, we don't always necessarily have to prove them ourselves. They've been proven, right? Make sense? Okay. Want to try it? there's an example. Why don't you try it, and we'll go through another example tomorrow, maybe. Okay, but you can grab the Chromebooks. There's an assignment up for 2.5, which is kind of just a warm up, or for 2.4, which is kind of a warm up for this one. And I'll put an assignment up for 2.5 also. Very short.
Lost my hype and you're not